Very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 6 students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 6th, our ongoing 6th chapter, light. And today we are entering into session number 4, probably the last session to complete all the concepts and applications of light. So we'll continue where we left in last class. But before that, let us recall what we learned in the earlier 3 classes, right? So as you know, we started with the definition of light. Light is a form of energy which makes sensation on retina. Whenever light falls on retina, we can able to identify any object. That means it is creating some sensation on retina. Like how sound creates sensation on eardrums. Right? Such a wonderful form of energy without which we cannot imagine our world is called as light. Light always travels in straight line, which is also known as rectilinear propagation of light. We have seen some small activity to prove that. So all the objects available with us, like iron, wood, stones, paper, glass, so many, how they behave in presence of light. Based on their behavior, all these materials are classified into transparent substances, translucent substances, and opaque substances. The substances which allows the light to pass through them completely are called transparent substances, like glass, diamond. The substances which partially allows, slightly allows light to pass through them are called translucent substances, like butter paper, oil paper. And last category is opaque substances, which does not allow the light to pass through them, like wood, stone, metals, all comes under opaque. Either they can be homogeneous or heterogeneous, no matter. But the main classification is 3. Then we learn about the very important property of the light, that is reflection. Whenever light falls on opaque bodies, reflection is the property of light. Body must be opaque. When light falls on opaque body, it bounces back into the original medium. That bouncing back of light into original medium is called reflection. And we have seen reflection may be either regular reflection or irregular or diffuse reflection. When light falls on smooth surface, reflection is regular. When light falls on irregular or rough surface, it is a diffused or irregular reflection. Then in the last class, we discussed about even shadow and image also, right? Shadow, we have seen whenever a light is obstructed by the path of light, there is an obstacle or there is an opaque substance, the image of the object is formed on the screen. So image is always, that is, shadow is always black in color, irrespective of color of the object, right? Then we have seen the conditions for formation of shadow. There should be one object, source of light. There should be one object which obstructs the light. And third one is screen. to catch the shadow. Then we have seen about images also. Image can be either real image or virtual image. Real image can be caught on the screen, whereas virtual image cannot be caught on the screen. So today we are going to discuss about how to talk to mirror. What is plane mirror? See how wonderfully they are showing the. Okay. So as we move to today's part, we have seen the last class about real image and virtual image. So this is the difference between these two, real and a virtual image. Virtual image is formed at the point where ray of light after reflection appears to meet, whereas real image is formed in the point where rays of light actually meet. It cannot be taken on a screen. It can be taken on a screen. It is always erect. Erect means reverse. Erect means straight. It is always inverted. Inverted means reverse. In case of real image, we can see the inverted, whereas virtual image is always erect or straight. So these are the two types of images. Now we'll come to very interesting part about characteristics of image formed by plane mirror. Hope every one of you have plane mirror at home. Plane mirror at home where early morning when you wake up, we go and see our face. That is itself a plane mirror. Right? So after going home, you can do the practicals of this plane mirror. All the characteristics you can verify. You yourself can verify. Right? See, one by one we'll see. Number one, the image formed in the plane mirror is virtual. Image formed in the plane mirror is virtual. When you see yourself in the image, you cannot catch you. If you go and see backside also, you cannot find you. Because we cannot catch it. It cannot be received on screen. Right? The image formed in plane mirror is erect, straight. It is a straight image. However you are standing, like that only you can see yourself. Straight only, not reverse. First one is, the image formed in the plane mirror is virtual, which cannot be received on a screen or cannot be caught on a screen. Second one is, image formed is erect. Third, the image in the plane mirror is same size of the object. Same size. If you place pen near the image, near the mirror, the pen size and image size always same only. When you are standing in front of the mirror, you can see our same size and mirror also. Not different. Not less or more. The same size. Fourth one. The image formed by plane mirror is at the same distance behind the mirror as the object. How far you are standing away from mirror, that much far image also formed. That is, the distance between image to the mirror is equal to mirror to the object. Same. And lastly, the image formed by the plane mirror is laterally inverted. For example, I am raising right hand in mirror. Go and stand in front of mirror. Raise your right hand. It looks like left hand in the mirror. If you raise left hand, it looks like right hand. That is called laterally inverted. This is the only difference you can find in the plane mirrors. One is the image formed by plane mirror is virtual, erect, same size as object, and same distance. And finally, it is a laterally inverted. So I am raising my hand. It looks like a left hand for you. Actually, I am raising right hand, but it looks like left hand for you. That is lateral property. Now I am raising left hand. It looks like right hand for you because I am a virtual image. In same time, in a teacher, in your classroom, do same thing. Right look right only, left look left only. But because I am virtual here, I can see the character called laterally inverted. See here, the example also given. How P can be seen here. P, When you place the P here, because of the reflection, the P becomes reverse. That's why when you see ambulance, in ambulance, the letters will be written reverse. So that the person who is viewing from the mirror can see correct. Observe carefully in the ambulance when you observe. The letters ambulance will be written in the reverse, inversion method. So that when you are seeing through the mirror, any four-wheeler, two-wheelers, they can see that word ambulance straight. Because the image formed by the plane mirror is laterally inverted. Right? Now, we can see here. What is lateral inversion is given explanation. Right? The phenomena of left appearing light and right appearing left on reflection in a plane mirror is called lateral inversion. The right of the object is transformed into left of the image. See here. This is actual P. But after reflection, light passes and reflected here, and it will look like a inverted P. Clear? You can check all these characteristics. All these you can try at home after going home, or if mirror is there in school also you can do. Very simple. And now uses of plane mirrors, where plane mirrors are used. So you can see plane mirror used as a see ourselves. That is, home we use the plane mirror to see ourselves. Then plane mirrors are fixed on inside the walls, certain shops like jewelry shops, sweet shops, to make them look bigger. So when you go to any sweet shop or jewelry shop or any malls, we can find so many mirrors to make the object visible very bigger. Okay, or beautiful. Then plane mirrors are fitted at the blind turns of some busy roads, so that drivers can see the vehicles coming from the other side. By this, we can prevent the accidents. So when you go to ORRs or any other big roads, highway roads, we can find the mirrors so that drivers can see the vehicles coming behind them clearly. Plane mirrors are used in making periscope, that we'll see next. In periscope also, we'll use the plane mirrors. Right? So, plane mirror, characteristics of plane mirror, uses of plane mirror. That's what we have seen till now. Clear? So the image formed by plane mirror is always erect, virtual, same size as object, same distance of object. Suppose, see, stand in front of a mirror, you come little close to mirror, your image also will come. You go back to the mirror, your image also will go. Correct or not? That you can see it. Right? So before going for the next topic, that is kaleidoscope or periscope, we'll see the one video on plane mirrors.
Explore plane mirrors and the characteristics of the images they form. By the end of this topic, you will understand how plane mirrors reflect light and what kind of images they produce. A plane mirror is a flat, polished surface that reflects light. The reflection happens from the silvered surface behind the glass. This is the type of mirror we use in our daily life, such as bathroom mirrors, dressing mirrors, and decorative mirrors in homes. An opaque surface reflects light. All the incident rays coming from a point source reflect in a predictable parallel way. Because the reflected rays maintain the same relative angles, the image that we get is sharp and well defined. Plane mirror gives regular reflection and therefore the images are clear. O is a point object and dash is a mirror. Let's consider an incident ray. So this is the incident ray OP, and here you can see the reflected ray. It obeys the law of reflection. This is the second incident ray OQ, and QS is the reflected ray. So now if we trace the reflected ray backwards, they will appear to meet at a point, and that's where the image is formed. So at point I, the image will be formed. It cannot be obtained on a screen. It appears behind the mirror at the same distance as the object in front of the mirror. When we place a large object in front of a plane mirror, each point on the object sends rays that reflect according to the law of reflection. The reflected rays appear to come from behind the mirror, forming a complete image of the object. Images formed by a plane mirror are always virtual, upright, laterally inverted, and of the same size as the object. The image appears behind the mirror at the same distance as the object in front of it. Location of the image is behind the mirror. Orientation, it is always upright. Size, image is exactly the same size as the object. Type, the image is virtual. Special feature, yes, the image is laterally inverted, meaning that left appears as right and right appears as left. That's why when you raise your right hand, the mirror image raises its left hand. Now let's talk about a real image. Unlike the virtual image,
okay, this is not required for us right now. One more is this simple explanation for the
video, we know what virtual images are. Virtual image is the image which appears to be formed at a position behind the mirror. But in reality, it isn't formed there, as no light rays reach behind the mirror. Now, the image formed by a plane mirror has some properties or characteristics. One of the characteristics is what we've already seen. The image formed by a plane mirror is virtual, or in other words, it's not a real image. The other characteristic of an image formed by a plane mirror is that the image formed is always erect or upright. For instance, if you look at your image in the mirror, you will see that it's straight or erect. But will it always be erect? Not necessarily. Maybe it's inverted. Well, we can think of inverted as opposite of upright. Yes, an inverted image means an upside-down image. Concave mirrors can form inverted images. The plane mirror never forms an inverted image. The third characteristic of an image formed by a plane mirror is that it's of the same size as the object is on the other side of the mirror. For example, if the height of this person is 4 feet, then the image's height will also be 4 feet. And if I bring the plane surface of the circular coin near the plane mirror, then both the coin as well as its image will have the same diameter. The image formed by a plane mirror is not upside down, but it's laterally inverted. What do I mean by this? When we raise our left hand, the image in the mirror raises its right hand. Our left is the image's right, and similarly, our right is the image's left. So an image follows left-right reversal. So we say that an image formed by a plane mirror is laterally inverted. Now we come to our last point. Finally, the image formed is at the same distance from the mirror as the object is. You can verify this observation yourself. All you need is a chessboard and any chess piece, say a king. Keep the plane mirror at the edge of the board as shown. Look at the position of the king as well as its image. Are they both at the same distance from the mirror? Well, you can count the number of squares in front of each. For the object, there are 7 squares in front and the same for its image as well. You can move this king anywhere on the chessboard and find out if its image is always at the same distance from the mirror as the king is. So these were the characteristics of the images formed by a plane mirror. Let's quickly review them. First, the image formed by a plane mirror is virtual and not real. Second, the image formed is always erect or upright. Third, the size of the image formed is the same as the size of the object placed on the other side of the mirror. And lastly, the image formed is at the same distance from the mirror as the object is. In the next video, we
Right? You understood now? Is it clear about our plane mirror? Okay? Now, after knowing about plane mirror, characteristics and uses, we'll come to some interesting devices. They're called optical devices, which works on the so many principles of reflection. One is kaleidoscope, other one is periscope. So, you know everybody very well, you might have learned in the lower classes, kaleidoscope works on the principle of continuous reflection. Right? So colors will come. Suppose if you see in olden days movies, in olden days, the person used to come with the camera to show the pictures. We used to bend and see in the cameras. We'll get the multiple color pictures. So see, that is kind of device is called kaleidoscope. 3 rectangular plane mirrors. See, 1, 2, and third side also will be there. 3 mirrors will join like this, like form of rectangle. Plane mirrors are placed such that the reflecting surface faces each other. The mirrors are bound together by string. The system is placed in a cylindrical tube of suitable size. This is a cylindrical tube. So 3 glasses will take, rectangular glasses, and placed like this. 2 like this and third close. They are placed in a tube. So here every reflecting surface faces each other, all three. Okay. Glass bangle pieces. Glass bangle pieces are paper bits of different bright colors are placed in the tube. Looking through the open end of the tube, we find different beautiful patterns that are obtained on the rotating tube. When you keep rotating, you have to place some broken glass pieces or colored papers. Then if you keep rotating, because of continuous reflection, there are 3 reflecting surfaces are 3 glasses. So light continuously reflects and gives out the multiple colors. It is nowadays used in the designing also. All the top designers of cloth designings and all, they'll use a digital kaleidoscope to design the clothes also. Wonderful application of day-to-day life. That is called kaleidoscope, which works on the principle of multiple reflection, you can call it. Multiple reflection of light. Not one reflection, because there are 3 mirrors are there. There is a multiple reflection. Because of that multiple reflection of light, the colored glass pieces or colored papers are appears to be brighter and brighter. You can see the wonderful brightness. Such a image, such a device is called kaleidoscope. Another one is periscope. It's very interesting actually. In olden days, in war, during the war, the soldiers used to this periscope to observe the enemies behind the wall. So they are bent towards the wall and they place the periscope and they see how many people are coming, how the attacking is going on, everything, the position of the enemies. This also works on the principle of reflection only. Here there are 2 plane mirrors which are placed at the angle of 45 degrees. See, here one plane mirror is there, here one plane mirror is there. So suppose the object is strikes here, 45 degrees angle, so it come back like this, again strikes here and comes out to see with the eye. You can observe from here, object is there here. Suppose say this entire thing is wall only. We place on the wall, you can see the object clearly, or we can see the enemy's target. Wonderful. These glasses are right 45 degrees. 2 glasses. See here. You see the application. Plane mirrors are used in the construction of reflecting periscope. A reflecting periscope works on the principle of reflection of light. The reflection happening here. Here object is there. The light from the object comes and strike the mirror here. After reflection goes straight and strike the another mirror which is at 45 degrees and it comes out to your observer. It consists of cylindrical cardboard or wooden tube bent twice in right angle. Here it is bent once right angle, here also right angle. Right? Two plane mirrors are fixed at the bent tube at the angle of 45 degrees which side. Here one mirror, which are 45 degrees. Right? The parallel ray entering the object strikes the plane mirror at an angle of 45 degrees, hence are reflected through an angle of 45 degrees using principle of reflection. You know, angle of incidence is equal to angle of reflection. And image of the object can be viewed from the other end, from here. Periscopes are used in situation of see objects to situation to see the objects on the surface of water in trench warfare to observe the movement of enemies. By using them, you can see the objects present in the water also, and also can see the enemy's position. Such a wonderful optical device is periscope. What? Periscope. So kaleidoscope, it is a multiple reflection. Periscope works on the principle of simple reflection. Now one more is there before closing, that is pinhole camera. Pinhole camera, camera without lens. You can prepare kaleidoscope also. You can prepare periscope also for science space and all. And of course, you can prepare the pinhole camera also. A pinhole camera as a simple camera possible. It consists of light-proof box, some sort of film and a pinhole. Pinhole means making small hole. When light goes to the pinhole, here is a pinhole. Make hole on the cardboard. Hole, it creates an inverted image at the back of the box. See, we kept the candle straight, but it shows the inverted. Reverse image is formed. So a pinhole camera is simple camera used in the photographers. Apart from the artistic reasons, it is also used in the solargraphy to observe the sun's movement in the sky and use the eclipse. In this also there are high standard cameras are there. So a pinhole camera is a simple camera possible. It consists of light-proof box, some sort of film and pinhole. The pinhole is simply extremely small hole like you would make with the tip of the pin in the piece of thick alumina foil. So a simple way you can construct the pinhole camera by using the cardboards and okay. So when you see the simple working is nothing. It is a luminous object AB such as lighted candle is placed in front of the pinhole camera. An inverted AB, A dash, B dash of the candle is obtained. Just now we are seeing the picture. Tracing paper. This picture A dash, B dash is called image. The image obtained is upright, down. That is reverse, inverted. The reason is that light travels in straight line path. Hence, light from the upper point A candle passes through the pinhole, strike at the A dash. Right. So, the size of image by size of object is equal to distance of image by distance of object. When object is close, the image also close. When you move the object away, image also forms very away. So, when you see the characteristics of also pinhole camera, it is real, formed on the screen. It is inverted on upside. It is generally smaller in size than the object. Object is large, but image forms very small. That is called diminished image. So this is about the pinhole camera, how it works. And you can see the video also on this. I'll show one video on kaleidoscope.
Hi, Odie. Odie, where are you? Oh, Did you make a periscope? Wow, Odie, that's amazing! We weren't able to see you. Were you able to see us? How is that possible? Let's find out! Periscopes are used to see objects that are not on the same level as the observer.
See. Here you can see how they are seeing. He's here. Nobody
Mirrors
can see him.
inside
He
the
can see the
periscope bounce
objects
the
on the other
light
side.
towards the observer. In order for the periscope to work, the mirrors must be facing each other and must be at a 45-degree angle. Light enters the periscope and hits the top mirror. In our experiment, the light hits the mirror at a 45-degree angle. The light then bounces off the mirror at the same 45-degree angle, basically creating a mirror image of itself. As the light moves down the periscope,
Straightly
it
come and
hits
again
the
hit the
second
mirror.
mirror, again at a 45-degree angle. The light bounces off the second mirror at the exact same angle. And this is how we are able to see images using a periscope.
Yes, what na? For periscope we are clear. When you see the about kaleidoscope, very interesting.
Hi, Odie. Odie, where are you? Oh, there you are.
Multi-colors you can see. Because it's form multi.
Did you make a
multiple
periscope? Wow, Odie, that's amazing. We weren't able to see you. Were you able?
Okay, so this is also same, I think, Kaleido, na? How do you work? How do you periscope only given here also? Okay, so that is about the total light chapter. Today we discuss about what is plane mirror, characteristics of plane mirror, uses of plane mirror, periscope, kaleidoscope, and pinhole camera. Okay, so with this we are done. We are done with this chapter. You practice the level questions, conceptual questions. If any numerical problems are there, go through the key given to you already for teachers, and you can finish up this work and maintain the separate notebook for this, so that next class we meet to discuss about the chapter electricity, which is very important again. Probably the last but one chapter. We'll complete the 8th chapter also early as possible, and we go for the revision where we can do all the worksheets, right? So that's all for today. So keep talking to you in mirror and observe the physics in the plane mirror at home. Thank you very much. Have a wonderful day. Thank you.